Hello all, in this entire submodule we will learn what are the various distribution plots or what are the most often used distribution plot in context of real world. Then later on we will have a code walkthrough because there is something that makes our task easier in order to understand what actually the distribution plot is all about. But first and foremost, let's have a intuition on all these plots. So first and foremost, let's understand again, typically there are three types of this. The first is my distribution plot that is often used in context of distribution. The second is my box plot. Again, in general, box plot is typically used when you have to understand the 5-point summary of a data. Again, we will discuss these things in great detail once we will touch upon what is box plot. The third one is something known as viral plot. So let's understand one by one what exactly all these plots are all about. Again, the distribution plot that you have, this is approximately similar to the histogram you have, approximately similar. The only difference is that the moment we perform the smoothing, on top of the histogram we have, we will end up getting the distribution plot. So if I have a histogram like this, so let's say, okay, this is the histogram of, let's say, rating. So on x-axis I have a feature, on y-axis in histogram I have a count or I have a frequency. So let's say I have all these bars. This is the first bar, this is the second bar, this is the third bar, and let's say this is the fourth bar. So I can have values as 0, 1, 2, 3, 4. Here I can have count as, let's say, okay, 1k, 2k, so on and so forth. So this is what my histogram is all about, because it is telling that what is the frequency if I have a rating between 2 to 3, or if I have a rating as, let's say, 2.1, what is the frequency? This is what my histogram is telling us. But if I will perform smoothing, now let's understand what the smoothing is all about. So what we will do is, in smoothing, what we will do is we'll say, okay, with respect to each of the bar you have, let's find out what is a middle point. Let's say this is the middle point. This is the middle point, this is the middle point, this is the middle point, and let's say I have one more bar, so let's say this is the middle point. So if I will map this, or if I will join this, it will approximately like this. Approximately, I'm not saying exactly, it is approximately. So this is what exactly my distribution plot is all about. This is what my distribution plot is all about. Again, we have one more difference. On histogram, on y-axis, what we have is, we have count. But the moment I say that, okay, this is a distribution plot. So on y-axis, what we have is, we have something known as a density. Let's say density is, let's say, 0.1, 0.2, so on and so forth. So if I say as, okay, let's say I have this point, what exactly it means? So if I have a distribution plot, and if I will say, okay, what is a percent of data? What is the percent of data that is available at that point? That's what actually my distribution plot will tell us. It means at any given point, what is the density of the data point that is available at that point? That's what actually distribution plot tells us. This is layman definition of what my distribution plot is all about. Again, in general, it is often known as PDF in general, which means probability distribution function. Again, oftentimes this distribution plot is also known as a density plot. It is also known as a density plot because for each of the bar it is showing what exactly the density, or for each of the point it is showing what exactly the density. Now let's understand what exactly is a box plot is all about. Let's understand that. So okay, if I say that, imagine this is my y-axis, and if I say that this is my x-axis. So if I say that, okay, let's say this is a rating feature. Let's say this is here we have all the different values of rating. Imagine 1, let's say 2, and so on and so forth till 5. And let's say this is the box plot we have. So in general, box plot will look like this. This is a box, and this is often known as whiskers. Let me tell you that. Okay. So this is often known as a whisker. This is often known as a whisker. Here we have a line which is known as nothing but a median. This is nothing but a first quartile, or you can also say as 25th percentile value. Again, just in a couple of seconds we will touch upon what is a percentile. Often known as it is often known as Q1. This is often known as Q3. This is often known as Q2, or you can say 50th percentile value. This is often known as Q3, which is my 75th percentile value or third quartile. This is all about a whisker. This is all about a whisker. So in general, what does this box plot tell us? It tells our Q1, our Q2, our Q3. And here we have a whisker and here we have a whisker. That's why it is often known as a 5-point summary of our data, because it tells the 5 metrics. It tells the 5 metric. Again, each and every library has its own implementation regarding the whiskers. Again, we have a very famous package in context of data visualization, often known as Seaborn. Similarly, we have something known as Pygale. We have something known as matplotlib, which is a base module in context of data visualization. So some module says that, okay, this whisker is nothing but a 99th percentile value. This whisker is nothing but a 1 percentile value. Some says, okay, instead of 99th percentile value, I will consider the maximum value of data set. Some says, okay, instead of 1 percentile, I will consider the minimum. So this whisker is typically library specific, or a package specific, or a module specific. So now let's understand. Again, the moment I have, let's say we have some few points, and let's say we have some few points. So it is typically known as an outlier. It is typically known as a low outlier, and it is typically known as a high outlier. Now let's understand what exactly outlier and what exactly the percentile and what is my quantile. Let's understand that. So given a bunch of numbers, let's say from 0, 1, 2, so on and so forth till 10. So if I say that, okay, regarding to, if I say that, okay, this is my 20th percentile value. So what exactly it means? It means below than 2, there are total 20% of data point that are less than 2. That's what it actually means. Or you can say as there are total 80% data points that are greater than 2. That's how exactly you can think of. This is what my percentile stands for. Similarly, if we have 25th percentile value, it means below any specific value, there are total 25% data points that are below than that. So in general, 25th percentile often treated as Q1, it means first quartile. Then we have 50th percentile often treated as Q2, second quartile, which is nothing but a median, because median is nothing but a middle value. What is the middle value of my entire data? So if I say, okay, given a bunch of numbers, what is the middle value? What is the middle value? I can simply say as my middle value is 5. So this is what my median is all about. This is what my median is all about. Similarly, Q3, my 75th percentile value. So let's understand what exactly outlier is all about. So given a bunch of numbers, let's say 10, 12, 14, 16, so on and so forth, let's say till 100. But the moment I have, let's say, a number as, let's say 1 million. So this number will be treated as an outlier in context of all these numbers. It is often treated as a high outlier because this is very high in value. Similarly, if I have a bunch of numbers, let's say 10, 12, so on and so forth till 100. But the moment I have a number as, let's say 0.000001. So I can say as, okay, this number is a low outlier in context of all these subset. In context of all these numbers. That's what actually my outlier is all about. So we have understood the distribution plot. Along with, we have understood what exactly is a box plot. So if I say, okay, what is my viral plot? So in general, viral plot is nothing but a combination of distribution plot plus box plot you have. So if you need the distribution as well as the box plot of your data, it's always good to go with the viral plot. That's what my viral plot actually stands for. Again, We will have a look on how exactly my violin plot looks like once we have a code walkthrough in the next session. So that's all about it. Thank you. Have a nice day. For those of you who have any doubt, please utilize the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.